Hi, I'm Wenliang Shan, and in this video, I will be demonstrating my implementation of the Cloud Pulse system for pulse detection. Um, okay, so we will start with the API source files. One will be the request demonstration. So as we can see, this function will receive a pulse request entity. What is that? It will be a ID and image, and format will be a JSON string. After we get the request, we will process the image. So what we are doing here is just we decoded the image. After we get the image, we will just detect any persons in this image that is moving or and there's something to specify that we will run this detect pulse in a executor, which is a thread pool. The reason to do this is because this model can only allocate one picture one at a time. So to enhance the performance of our API, we have to put this method into the executor for better performance. And about this executor, it is quite simple. We just put it in the async loop. And the executor we only set the max workers to be 6. After we get the result from the thread pool, things can be quite simple. We can just return put these results into this JSON format files and yeah, there is a response. That's all. And for the annotate API, it is quite similar with the previous one. Core difference is we run this method after we get the result from the detect pose method. We create an annotated image. So what we are doing here is just we get the key point from the result of the detect function and we just draw the key points. The demo code is quite insufficient and the quality of detection is really low. So we updated somewhere like we adapted a new skeleton model. The XY axis has to be inversed, and something other things like the pre-process of the image has to be another function like process with paddings. Next, we are going to talk about the Docker file. Here's the Docker file created for this image. We specify the Python version and we use a Slim for a smaller outcome of the image. And we will run the system dependencies for OpenCV, which is required to run this model too. And after that, we will copy and run the requirement text. This is the environment to run the source file we just demonstrated. And next thing is we just copy the model and the source file, which is a minimum of requirement to run the whole system. And after that, we just expose the port to the external network. And after that, we just simply follow the wake for applied class to configure the Kubernetes and other cluster required files. We firstly install the Docker, and another thing is the Docker adapter. And next we install the kube ADM, kubelet, and kube control. I can show you the current state of our server. We can just simply run this command. We will see we have three nodes joined together, master and two workers. We can check the cluster info. So you can see the Kubernetes control plane is running on the master, the same as this one. And the CDN is running appropriately. After this file, we can check our deployment file. In this file, we designated the version number and the kind of the deployment, and we have the namespace We also have the label for the app, and we also assign two replicas for the initial pods when running. And we also have the CPU and memory limitations, same as the requirement files. And we also specify the image names and the container port is the same as the Docker file. And another is my service file. So this one is simpler. And we have the same name and namespace. And we have the node port 30,000 exposed outside to the external network. After that, to build the Docker file, we can just run this command. We will just specify the system, the running system, and the CPU, so that it will ensure our image can be run successfully in this way. And so after we build the image, we will just push. We have to tag it first. After that, we can just push the image to the Docker Hub. We'll be running this pull command. After that, we will have our Docker image. Run, we simply just apply the my deployment file, and another is service file I just showed you. The next thing I want to show is the instance on our Oracle Cloud. So we will have 3 instances in total. If we can check the one of the master, we can see the subnet is in the same subnet. So we can see the security list. We open the 6443, which is a Kubernetes port. And we also open the other port according to the Kubernetes official document. This port will be exposed to the external internet. About the locust file, we have the two tasks for it. The first one is to test the detect API. Another is to test the annotate API. The two things are quite similar. We just create the payload and we uh, build the payload and post it to the API. And if the successful status code is 200, it is successful. And if not, it is just a fail. The annotate API is exactly the same. The key difference is just the annotate. So I just connect to the Nectar SSH and I can run the file. And in this way, we can also test and in and in this we can also test the load balance of our server. We can firstly check this one. The log is printing, and we can check about it. It shows our load balance is clearly running right now.